Welcome to Chapter 7, Part 2. This covers 7.4 and 7.5. I'm going to try something a little bit different with the notes today, and we'll have an opportunity for you to give me feedback and see if this is any better than the notes videos that I was doing previously. So what I'm planning on doing is we will cover the notes, and then I'll go back and go through the practice problems at the end. And that way it'll give you a little bit more opportunity to pause the video and take a break from looking at the screen so much. So in 7.4, our objective is to find and use relationships in similar right triangles. Now this is a very visual section. And what we'll be doing is we have this triangle here, and what we're actually going to try to do is split it into 3 different triangles. So the one that's hopefully a little bit easier to see is this big triangle, right? And that is QRP with the right angle at the bottom. But there are also 2 more right triangles in here. There's this small right triangle here, and we know that it's right because it's supplementary to another right triangle there. And so that is here, SQP. And then there's a third right triangle here, this medium-sized triangle. And that is another right triangle, but SRP. And so whenever you see this type of triangle with an altitude, that's this line that's perpendicular to the base, that's going to give you 3 congruent angles for your triangles, but different sizes. And so it gives you 3 similar triangles. A little bit of vocabulary. For our big triangle, the orange triangle here, QP and PR are touching our right angle, so those are the legs. And then QR, which is opposite our right angle, we call that the hypotenuse. For, again, that orange triangle, the segment SP is called the altitude. And that's when we go from a corner and we are perpendicular to the other side. So that's the altitude of a triangle. Now, non-right triangles also have altitudes, but we are going to focus on this specific case for now. And so, as I drew in the diagram above, what this will actually give us is 3 similar triangles. So we have the purple triangle here, triangle ABC, and then we have the small blue triangle, ADC, and the medium green triangle, CDB. So we split the purple triangle. Think about if we cut it in half, it would make 2 more similar triangles. So how do we name these? Well, I actually like to take a pencil and write, here's my hypotenuse, small side, medium side, hypotenuse, small side, medium side, hypotenuse, small side, medium side. And that's, again, going to help us just make sure that we are naming these in an appropriate order. So if we start with triangle ABC, that's the purple triangle. A is between small and hypotenuse, so I start between small and hypotenuse, which in our small triangle here is still A. B goes along the hypotenuse, so I'm following along the hypotenuse, A, C, D. So just like when we're naming our similar or congruent triangles, the order is very important. Then we can also compare triangle ABC to the green one here. So starting between small and hypotenuse, that is C. Going along the hypotenuse takes me to B, D. And then for our last statement, it's these 2 triangles that we want to compare, the blue and the green. And so because we already named them in a very careful order, we can just keep that order. Triangle ACD is similar to triangle CBD. Okay? So we're going to come back and we're going to do the examples toward the end of the notes. So going not to the next page, which is all examples, but to the following page, we're looking at 7.5, where our objective is to use this side splitter theorem. So the side splitter theorem does exactly like it says. It splits sides, but in a very particular way. But this time, instead of looking at, we've talked about the mid segment where we connected midpoints. This time, it doesn't matter if they're midpoints. What matters is that they're parallel. Okay, so this side splitter theorem, and then we'll also learn about the triangle-angle-bisector theorem, which, as it says, is going to involve an angle bisector. So starting with our side splitter theorem, what we have is any segment inside of the triangle that is parallel to one of the bases. Okay, now what this does is it creates a similarity statement where we can say that these sides create a ratio with these other sides. Now I'm not doing congruence marks because, again, they are proportional, not congruent. And so what we end up with, we can say Jn over Nk, our first pair of sides, has the same ratio as our second pair of sides, Jm over Ml. Okay, we can also, instead of doing two sides in a row, we can do it by level. So we can say Jn over Jm equals, we did left then right, so we'll do left then right, Nk over Ml. So two different ways that we can set up that proportion. And then, again, skipping the examples for now, the triangle bisector theorem, if a ray bisects an angle, so we have this angle, any angle of the triangle is bisected, what we end up with is our proportion being the sides on either side of the ray are proportional to the sides on the other side of the ray. So we have CD over DB equals CA over BA, or again, a second way that we can write that, we can say CA over CD equals, started with this one, so we start with this one, BA over DB. Okay. So what I'd like to do now is go back and look at the examples, starting with the 7.4 examples. And now we're going to apply those three new concepts that we just learned. So in this example, it's on page 10, the first page of this note packet. We want to write the similarity statements for the three triangles. And the first step is to find and rewrite those three triangles. So draw the diagram. Again, it's going to be very useful to have colors. So I'm going to do orange as my outside big triangle. Z, X, Y. I'll use pink for my medium-sized triangle. And instead of trying to write them all facing the same way like they did in the example, I'm going to draw them in the same orientation as the diagram above. So my right angle is in the same place. Z, W, Y. And the small triangle here with the right angle supplementary to my other right angle to get W, X, Y. And then I'll go in and I'll label. Here's the hypotenuse. That should be the most straightforward to label because it will always be across from the right angle. And then we have to say which leg is smaller or bigger. So the smaller triangle will always be on the smaller leg. So if this is the small leg and this is the medium leg, then this is the small triangle and this is the medium triangle. The small triangle has the medium leg where the medium triangle has the small leg. So small triangle, medium leg, medium triangle, small leg. So that leg that these two triangles share, one will be labeled on this one, the small leg, the other will be the medium leg. Small triangle, medium leg, medium triangle, small leg. And then the last one is the opposite. So small triangle, small leg, medium triangle, medium leg. It's this one. Okay, it's going to take practice to get these triangles down. So if we want to write our congruent statements, we'll start with our big triangle, triangle XYZ is similar to X is between small and hypotenuse. So if we do our small triangle between small and hypotenuse is triangle X. Y goes along the small side. X along the small side takes W, Y. Then same thing, triangle XYZ is similar to, again, X starts between small and hypotenuse. Between small and hypotenuse is Y. Then we go along the small side. So we start here, go along the small side, goes to W, Z. For our last similarity statement, we just compare these two that haven't been compared yet. Triangle XWY with triangle YWZ. On the next page, for example 1, we want to write a proportion for the hypotenuse to the shorter leg. So we're looking at, here's my hypotenuse, is ZX. The shorter leg here is XY, knowing that we have two similar triangles inside here. Okay, so what we're going to do is we're going to set up a proportion using the legs of the triangles. Start with what we want. What we want is XZ. Okay, so that's a hypotenuse, then we need another hypotenuse. Well, XY is the hypotenuse of our small triangle. So if I draw big triangle Z, X, Y, smallest triangle is X, W, Y. So here's the hypotenuse and small side, hypotenuse and small side. So those are the two triangles that I'll use to set up this proportion. So XZ was the hypotenuse, XY is the hypotenuse equals hypotenuse. Our second ratio, we'll do small sides. So that's XY over small side is XW. It's not the only proportion we could have made. We could have made other ones if we had chosen to use, for example, a different side of one of the triangles. But this is the most straightforward way. And then again, naming the sides, you could have named them backwards. We could have called that ZX instead of XZ. So all of those naming techniques that we learned in the past few weeks still apply. For example 2, we want to set up a proportion for the smaller triangles below. So that means we need to draw out our smaller triangles. There's my right angle using my colors. Here's the big triangle in orange. And all I know for that is that the hypotenuse is 10. 8 plus 2 is 10. And then we have our medium triangle here. We know that this side length is 4. And we know that the other side length, or the other leg, is 8. And our small triangle we know that our small leg is 2 and our medium leg is 4. And so we can see that we have for our two triangles, the small leg and the medium leg, the small leg and the medium leg. So our proportion will compare small and medium legs. So I'll do pink over blue. The pink small leg is 4. The blue small leg is 2 equals. The medium pink leg is 8. The medium blue leg is 4. And we can see that this is a true statement, right? 4 halves and 8 fourths both reduce to 2. For the next example, I'd like you to try them and then put your answer into Edpuzzle, and then I'll go over them after you put in your answer. So for the first one, we want to find X and Y. So again, I'm going to draw out these triangles. So we have the big triangle here in orange. The hypotenuse is 12 and 4 together to make 16. The small leg is x. So this is hypotenuse, small, medium. And then we have our medium triangle here. Medium triangle tells me that the leg that they share will be the small leg. So y and 12. So this is the one that they share is small. The other one is medium. And then the small triangle the leg that they share for the small triangle is the medium side. So that will be medium, small, hypotenuse. So let's try and find x first. So I'm going to say, here's an x and here's an x. How do I set up a relationship between these? So I'm going to say small and hypotenuse, and I'm using the orange and blue triangles. So the orange, small, is x. The blue, small, is 4, equals. Orange hypotenuse is 16. Blue hypotenuse is x. So do you see how I'm putting these letters to guide me and make sure I set up my proportion properly? Orange and blue, small, and hypotenuse. To solve this, we can use cross multiplication to get x squared equals 16 times 4 is 64. Take the square root of both sides, always plus or minus when you take the square root. X equals plus or minus 8. X has to be a distance, so it has to be the positive one. X equals 8. For the second proportion, we want to solve for y, so I say which two triangles have y, and that's going to be pink and blue. And which sides are they on? They're on the small and medium sides. So start with pink, small is y. Blue, small is 4. Pink, medium is 12. Blue, medium is y. Cross multiply, we get y squared equals 48. Square root property, take the square root of both sides. Y equals plus or minus the square root of 48. Now the square root of 48 is not an exact number. So I'll do a quick crash course on square roots. When we're taking the square root, that means we're finding what factor is twice. So I can rewrite this. This was 4 times 12, and 12 is 4 times 3. So we have two factors of 4. That means I can rewrite this as y equals plus or minus 4 times the square root of 3. Now again, y is a distance, so it has to be the positive one. And if I'm leaving my answer exact, I would leave it as y equals 4 square root of 3. If I'm estimating, then I would put it in the calculator. And the square root symbol is just above x squared. So if you find 7, go up and to the left. The square root is just above that button. And so we would say 4 square root, we press second, and then the x squared button, 3. So when you type it, it should look like 4 times the square root of 3. If you hit enter, it will give you the estimation, the decimal estimation. This is only if it asks for decimal form. Then I would say 6.93. Y is approximately 6.93. If it does not say to give a decimal estimation, always leave your answer exact and simplified. Okay, for number 2 here, we again want to find x and y, so we want to draw out our triangles. So we have the orange. The hypotenuse is 4 and 5, so that's 9, x, right angle. Now what I'm going to do is I'm going to say I'm calling this small and medium triangle. And so that makes this the small side and the medium side. If it's not clear, you can just choose. And the nice thing about ratios is because it's a relationship, you'll end up with the same answer. So I'll call this one my pink triangle. Here's my hypotenuse. Whoops. Well, hypotenuse, we don't know the value of. And then the leg that is shared, the shared leg for the medium triangle is the small leg with a value of y and a value of 5 for the medium leg. Okay. So this leg that's shared on the medium triangle is the small leg. And then we have our blue triangle. X, y, 4. Here's the hypotenuse. The shared leg of the small triangle is the medium leg. Small leg, blue triangle. Now I can set up my proportions. If we're solving for x, I find the two triangles with x, and I say that's the small side and the hypotenuse side, so we'll do blue and orange, small and hypotenuse. Blue small is 4, orange small is x, blue hypotenuse is x, orange hypotenuse is 9. What you'll start to see is that the x's are never going to be both in the numerator or both in the denominator if there's only one side with an x. So we can cross multiply and we can say that's x squared equals 4 times 9 is 36. Square root property, put the plus and minus. X equals, I said 36, but then I wrote 39. 36. Square root of 36 is 6, so plus or minus 6. X is a length, and therefore it has to be positive. X equals 6. Same thing for y. I find the two triangles that have y. That is the pink and blue. Pink and blue. Which sides are they on? They're on M and S. So pink S is y. Blue S is 4. Pink M is 5. Blue M is y. Cross multiply, y squared equals 20. Square root property, y equals plus or minus the square root of 20. It's not a perfect square, so we need to factor. 20 is 4 times 5. 4 is a perfect square, 2 times 2. So y equals, taking only the positive because it's a length, 2 times the square root of 5. Okay. Using those same tricks, I'd like you to answer these two, and we will go over them in class. On the next page, looking at example 1 here, find the value of x in the diagram. So we're looking at this. What I'm going to do is I'm going to use colors to represent the sides that are proportional. So these are our parallel lines. That means I have these two sides and these two sides. And now I have an option. I can do pink over pink equals orange over orange, or pink over orange equals pink over orange. The important thing is the oranges have to be together either in the same fraction or both in the numerator. And the same with the pinks, together in the same fraction or both in the denominator. So kind of like our pattern that we were using on the last page, we want to set up, if I'm going to do pink over orange, it's going to be left and right fractions, or I could rotate this, I could say left over right, pink fraction, and an orange fraction. So now I have pink on the left is 12, orange on the left is x plus 1, pink on the right is 9, orange on the right is x. Now, remember I was saying that they shouldn't both be in the numerator or both be in the denominator if they represent the same side. These represent different segments, and that's why they're both in the denominator. So we can continue solving this with cross multiplication. 12x equals, give that some parentheses, 9 times the quantity of x plus 1. We will need to distribute that 9. 12x equals 9x plus 9 minus 9x. 3x equals 9. If 3x equals 9, divide both sides by 3, x equals 3. Same thing here. I'll use colors that are a little easier to tell apart. So I have blue and orange. So if I say, okay, I'd like blue and orange, left and right. So blue on the left is A, blue on the right is 12, orange on the left is A plus 4, orange on the right is 18. Again, by cross multiplying, 18A equals 12 times the quantity of A plus 4. Distribute. 18A equals 12A plus 48 minus 12A. That gives us 6A equals 48. Divide by 6. A equals 8. For our next examples, we're using the triangle-angle-bisector. So we're looking at these two angles are bisected. So I'm going to say I've got my orange side of the triangle and I've got my blue side of the triangle. I do want to point out in the examples above, notice my parallel lines did not have a color because we cannot use the side splitter theorem for the parallel sides. In order to use those, we have to use the whole triangle like we were doing before. Okay, so this only works for the sides that are split. This one, we only have an angle bisector. This isn't splitting across the sides. There's no parallel line here. Okay, so again, we're going to set this up. We'll say orange and blue. And what I'll do is I will do a side or a leg and a base. Okay, the base is the one that's cut. So you could say like whole and cut, or something that will help you remember to put these in order. So we'll do orange leg is 12, blue leg is x, orange base is 10, blue base is 18. Cross multiply. 12 times 18 is 216 equals 10x. Divide by 10, 21.6 equals x. Now, we can leave that as a fraction. You could also leave it as a reduced fraction. 108 over 5 if it's asked to leave it as a fraction. The reason it's okay to put this as a decimal is because it ends. So this is not an approximation, this is an exact value, right? I didn't have to round, I didn't have to leave off any decimal points at the end. Okay. For number 2, we'll do the same thing. We'll do orange and blue. So I'll do orange and blue, leg and base. The orange leg is x, orange base is 12, blue leg is 20, blue base is 16. I don't have to cross multiply this time because there's only one x and it's already in the numerator. I can just multiply both sides by 12 to get that x equals 15. Okay, our last section here. And what I'll do is I'll give you an opportunity to do each problem. So go ahead and pause the video, try the problem, put your answer in on Edpuzzle, and then I'll go through that problem, and then we'll do the same thing for each one. So try number 1, put your answer in, and then I'll lead you through number 1. then you can try number 2, and I'll lead you through number 2. So for number 1, we know that US equals 5, TU equals 16, QS equals 20, and we want to find UR, so we'll call that X. Now, can we use the side splitter theorem here? We would have been able to if we had the lengths for this side, but we're not given the lengths for the side, we're given the lengths for the parallel sides. And so what we have to do is we have to pull apart these 2 triangles. We have the bigger triangle in orange and the smaller triangle in blue. And so we end up with similar triangles by angle, angle. Our blue triangle is X and 16. Our orange triangle, the whole length here is X plus 5 and 20. And so our proportion, we can do blue and over orange, and we'll do side or leg and base, okay? So the blue leg is X, orange leg is X plus 5, blue base is 16, orange base is 20. And again, there are multiple ways to set up this proportion, but starting with the next step, no matter what, if you're cross multiplying, you should have the same equation. So we get 20x equals 16 times x plus 5, distribute the 16, 20x equals 16x plus 80, minus 16x, 4x equals 80, divide by 4, x equals 20. Now we don't want just x, we want side UR, but UR has the length that we called x. We should label it x equals UR, and so this is the same as UR equals 20. For the next one, for number 2, go ahead and try it, and then I'll lead you through it. So for this one, we want to find the length of BC, so we'll say that BC equals x, label it here as x. We want to say, are these 2 similar so that we can set up a proportion? They are similar by angle-angle similarity. We have a 102 degree, and we don't know the angle measurement, but we do know that they're congruent. And so we can label our sides. We have this side between the 2 angles, and then we have this side, which is next to the 102 degrees. And so we'll go orange over pink, and we'll go top and bottom triangle. So the top orange is 6, the top pink is 9, the bottom triangle's orange is x, and the bottom triangle's pink is 6. This time we don't have to cross multiply because x is already in the numerator. Multiply both sides by 6. 6 times 6, 36 over 9 is x, so x equals 4. And x is already the length BC, so we don't have to substitute it in. Okay, go ahead and try number 3. For this one, we're looking for the length of x. I'm looking at this, I say, oh, I have congruent angles. I don't know that these triangles are similar, but I do know that I can do the triangle-angle-bisector theorem that we were just working on earlier. And so I can set this up with my orange side and my blue side. So I'll do orange and blue, leg and base. Orange side, leg is x, base is 14. Blue side, the leg is 20, and the base is 8. Again, x is in the numerator, so I don't have to cross multiply. I can just multiply both sides by 14 to get that x equals 35. Try number 4. So this time we're solving for x. I have parallel lines, so that tells me we can use the side splitter. So I say here is one pair of sides, and then on the other side of the parallel lines, here's the second pair of segments that we're going to use. So I'll do right and left, blue and orange. Let's actually, because this is turned on its side, let's call it top and bottom. Top and bottom. So blue on top is x, blue on bottom is 8, equals. Orange on top is x plus 5, orange on the bottom is 12. Now this time we can't just multiply by 8 because there's 2 x's, so we do have to cross multiply to solve this. 12x equals 8 times x plus 5, distributing. 12x equals 8x plus 40 minus 8x. 4x equals 40. Divide by 4, x equals 10. Make sure you're answering the question. It didn't tell me to find both side lengths, just x, so we can leave it like that. Go ahead and try number 5. So here we want to find x. There's a lot going on here. So the first thing I'm going to do is I'm going to say, okay, if I want to use the side splitter theorem, I'm looking at this triangle with the 2 parallel sides. So P, Q, R, S, T. I know x, 2, 3, 3. I don't know this side, and also that's not going to necessarily help me get x, right? If I'm using my angle bisector, my triangle angle bisector theorem, then I'm using this triangle here with the bisected angles. So that's PQ. We don't need R, S, T. And here we know x, 3, 2 and 3 together makes 5, and I don't know, again, this segment, right? So in order to find x, I need this segment. In order to find this segment, I can find it using my side splitter. So if I say here's orange and here's blue, my proportion, let's call this A. I'll do orange, top over bottom, top over bottom. So we'll do blue, orange, top and bottom. So that's 2 over 3 equals 3 over A. We need to cross multiply to get A in the numerator, so that's 2A equals 9. A equals 9 halves. And I'm just going to leave it as 9 halves. You could write it as 4.5 if you prefer. Okay, and now I have enough information to use the angle bisector. And I'll do orange and blue. So I'll do orange, blue, leg, and base. So it's x over 3 equals 5 over 9 halves. So to solve for x, multiply both sides by 3. X equals, now the nice thing is that the calculator can do this all for us, or you can simplify by hand. So I'll show you how to do it on the calculator. We have 5 divided by, and then in parentheses, 9 halves, right? 9 halves is the whole denominator, so we'll put the whole thing in parentheses. Times 3. Enter. Okay, well, that is a continuing decimal, so if I want an exact answer, we need to go math, fraction, enter, 10 thirds. X equals 10 thirds. Okay, go ahead and try number 6. For this one, we'd like to find the value of m. So I'm looking here and I see we have here vertical angles. So these are similar triangles by angle-angle similarity. So I'll say, okay, the segment between the two known angles, we have our hypotenuse and the hypotenuse. Then we can have our other leg. We know we want to solve for m, so we need to use the blue sides. And then orange and pink both have both segments lengths we know, so we can use either one. It doesn't matter. I'll choose to use orange. Okay, and then we'll say right triangle and left triangle. So blue from our right triangle is m. Blue from our left triangle is 25. Orange from our right triangle is 8. Orange from our left triangle is 20. Now, because of the way this is set up, m is in the numerator, so we can just multiply by 25 to find that m equals 10. Okay.